Let's talk about another aspect of how computers work. Let's talk about something called parallel processing. Remember, we said in our meeting that the CPUs are people in our meeting, that they actually can interact with the whiteboard and can perform tasks that are being done. There's kind of two different kinds of parallelism. If we have multiple people inside of our meeting that are all able to work against the whiteboard, they could all be working on different problems. They could be using different sections of the whiteboard to solve different pieces of the problem. Someone might get interrupted by a phone call and have to deal with a different problem. That's being kind of like the problem is being swapped off in a computer where it's working on a different kind of task for a little bit of time, and then it comes back into the problem space. That's one kind of parallel processing. A different kind of parallel processing would be actually setting up different meetings and having different meetings going on in different meeting rooms. Those could happen where we actually have different computers. That those computers could have different CPUs, different people, and we've divided up the workload. We took some portion of the set of the binders involved and some portion of the agenda, or maybe we copied the agenda and just replicated portions of the binders, and we sent them out to different meeting rooms, and we had those go on. That's a different kind of parallel processing, but it is something that's quite often used. It's using multiple machines, multiple nodes of a computer system, a computer network, to try to solve the problem. Ultimately, if the problem has to be something where you bring back the results together, then we're going to have a centralized meeting at the end of all of those subordinate meetings to bring back the results back together again, to coordinate them and consolidate and get to the end result that we need from whatever the agenda was. If we're trying to pick the best winner for whatever competition was going on and the evaluations going on in multiple meeting rooms, we have to get back together and evaluate out of the winner of each room which one was the final winner. That's bringing back the results and having to consolidate back together again. You can also have, in certain instances, you can set up multiple meetings inside of one meeting room. You can do things that are called like virtual machines, where in fact you can carve off a piece of the whiteboard and you have a set of people that are running one meeting inside of the room and another set of people talking and working and collaborating in a different corner of the room on a different meeting. That all goes on within one computer, and that still is kind of a parallel processing going on, but you have two different meetings. They could actually be speaking different languages, going back to the language analogy, that maybe one is using a language that is Japanese, another one's using Spanish, in the same way that you could have two different operating systems working on a computer. Now, when you're doing that kind of virtualization of parallel processing, the actual room, let's say the room itself is in Spain, and that the hardware involved is a particular machine that requires understanding Spanish. Then our small meeting that's going on there, like a virtual machine, that might be having somebody they're working in Japanese most of the time, but then there's a translator at some point that goes from Japanese into Spanish in order to interact with its environment, in order to actually finish the processing and do the pieces that are involved. That can be the function of the virtual machine that does that. So you see how these kind of things come together. You can take this meeting analogy in a lot of different ways. I think it's helpful in understanding how computers work, and the better we understand how computers work, the better we can apply them to the problems that we need to try to solve.